Hi, Dolly Remler back for part 2 of secondary data. Now we're going to talk about the different ways and places and avenues for actually acquiring secondary data. So a big kind, increasingly important research uses administrative record data. And that's financial records, income expenditures, employee records, patients, students, clients. We all know there's a gazillion pieces of administrative data on us. Some of the traditional forms were things like vital statistics, birth records, death records. There's unemployment claims, crime records. So a lot of formal research used by academics uses this, but also increasingly organizations do their own internal research and analysis with their own administrative data. Some of you may already do that and may be familiar with this. There are some challenges in adapting administrative data for research and analysis. So some organizations still rely on paper records. Far fewer than when we wrote the second edition, but it is still a thing. And if you want to go back in time, oh boy, then you may really have paper. Also, the fields or variables, they need to be cleaned, coded, reformatted. That's especially true if it's recorded as text. How many ways do you think you can write diabetes in clean text? That's why we have all those drop-down menus to try and avoid that problem, but still, what people write is inconsistent between two different variables. You have to lump things together. You need them in a different form. And a big problem is that a lot of administrative records are in relational data sets, relational databases, Access, a whole bunch of these things where there isn't just one unit of analysis. Like maybe they want to look at it by company name, or maybe they want to look at it by product or by order. So there's a lot of different ways you can do it, which is precisely why relational databases are so valuable. But to do traditional statistical analyses, you have to put them into a flat file like SPSS, data, or for many of us, what you'd see in Excel. So, there's a whole bunch of different flat file data sets you could create with this relational database. Data cleaning, that's what really takes all the time. So much analysis today is so fast, but oh my God, the data is a mess. So you have to verify it. Is this consistent? Code it, reformat it, interpret it. Statistical software doesn't always handle non-numeric data easily. Administrative staff make errors. It can be incomplete, inconsistent, figuring out what should be in that missing database. Administrative records also bring a lot of ethical issues. So I'm sure you can imagine that CUNY has your data with your name on it and a lot of important things about it. A lot of people do research with CUNY student data. I have. An obligation that they have is to make sure that the individuals remain non-identifiable. If they give data to outsiders, those outsiders can't be able to figure out who is that. Sometimes with much, much higher security, people will get permission to have it be identifiable to the researchers. So for example, to merge or link data sets, I get some CUNY administrative data, I merge it with some data that I collect myself on an intervention. I can do that, but I have to have a lot of security to make sure that nobody else, no outsider can ever identify who has which variable. With the growth in electronic data, obviously protecting privacy is growing concern. And in healthcare and health insurance, there are a whole additional set of strict regulations. So now think about data in your field that you're interested in and administrative data records that would be useful. What are the technical, logistical issues in trying to use that data for your research? What about the ethical issues? If you want to do research for your capstone on your own organization, now is the time to think about this, because there'll be a lot of ethical, technical, logistical, and quite frankly, political in the sense of internal politics to your organization to get this data. But it's worth doing. You could get something really great that is really interesting, that you're interested in, that your organization is interested in, and that's useful. If that's not possible, still think about some administrative data in your field. Pause the video, write it down. So now we're going to turn to data that is published in a summary form of some kind. And again, it used to be that such things were valuable and they were only in paper and they were hard to get, but now we see tons of this all over the place. So there's tables of aggregate data on the internet from government, institutions, time series panel, and so on. So we just have some examples in the book. What you're seeing now is data from the Census Bureau about numbers and percent of people below poverty. We have the aggregate for the US, but they also have it state by state. You could make the state your unit of analysis and get that. Increasingly these days, you can download this aggregate data. It'll be there in comma delimited format, CSV, so that you could pull it into Excel. It might already be an Excel spreadsheet, and so on. You can also get, this is the same one, just more states, but you can also get it in time series. So now we're getting from the FBI Uniform Crime Reports, you have numbers over years, you have the number of victims broken up by sex and race, and you also have the rates for them. And again, increasingly you can download that directly as well as getting the paper tables. But you also, for a lot of data, can get the microdata. That's the individual level data, such as the U.S. Current Population Survey, which is gathered by the Bureau of Labor Statistics and used to generate unemployment statistics and poverty rates and so on. In the book, we have pages and pages of major surveys, far from complete, but a lot of the best known ones. Find one. See what makes sense. See what could be useful for you. Learn what's in it. So how would you access such data? So often it's sitting there, of course, without the identifiers, and with some variables maybe missing or aggregated or so on to make sure you can't identify people. And it often comes in lots of forms, ready for some statistical packages or Excel, and so on. But you're going to need a code book and documentation to understand what this stuff is. How are the data collected, coded, weighted? You know, if there's a categorical variable 1, 2, 3, 4, 5, what are 1, 2, 3, 4, and 5? Remember that complex survey sampling and how you may need to weight this and what weights you should use. Some organizations now, including Census for several of those data sets, have online data analysis tools. You can go to their microdata, but you don't even need to download the microdata. This is from the Department of Education, National Center of Educational Statistics. You can create your customized aggregate tables. The software will do it for you. Boy, it wasn't like that when I was young. There are a lot of public use data sets, tons of them. There are data archives that make it easier to find such things. But again, there's ethics of these. They reveal details of individual survey respondents, and so you must not try to identify people. That's, you know, increasingly possible. The private firms collect all this data out there and they sell it. And so people can try and merge it and then figure out who people are. So you must promise not to do that and in fact not do it. So that linking data is kind of just what I was talking about. And there's lots and lots of linking of data going on now. Maybe you do a survey, you can link it with administrative records. You can link data through GIS, graphical information system. So we have a survey of health behaviors from people. You can link it to the availability of parks in their area. You can link quantitative and qualitative data. People can conduct focus groups, link it to surveys. So now I want to talk about this growing field called big data, right? So, well, what is it? What's big? So the first idea is there's lots and lots of variables, and often many different types of variables, often coming from a variety of sources. There are many observations, but that's actually not so unusual. People have been working with many observations with structured. One of the biggest things about big data is it's typically unstructured, not flat files, nor is it that nice structured relational database. You want to think about us sort of clicking through the internet. Each place we go, we make a different branch, and people made different branches. How would you structure that data? Honestly, I don't know. This is not a field that I know, but it's growing rapidly and, you know, big. Another thing about big data and this idea of us sort of living electronically or virtually is that this data is in real time. Like it's constantly changing and they're constantly collecting it. Think about the data analytics that you're all used to, but on a much bigger time scale. Despite all that, big data is kind of a vague term. It's widely used, but the meaning is somewhat disputed. So when it started, people talked about the 3 V's. Volume, lots of data, but they really kind of meant the variables, not the observations. Velocity, oh, it keeps coming, and definitely variety. So some people will use the term big data to mean things like the enormous administrative data sets the IRS has, particularly if it's merged to Social Security data and things like that. Other people don't. I was at a conference where they had a session called Big Data, and there was this big IRS data merged to other administrative data sets. And the discussant was, well, actually, I don't consider that big data. Big data is kind of us living naturally on the internet. Okay, both are growing. You both use growing. Do you count traffic sensors? Do you count traffic sensors when they're merged to GIS? Do you only count them if you're getting some commercial data from people's cell phones as they're driving? In any event, all of these are big and increasingly used. So far in talking about big data, I've just talked about the actual data. But some people use the term big data to mean what they do with it. So the variety of big data and their complexity can be mind-boggling. And there's a variety of new software to address on this. Hard to learn this software because the people who know it all work like 100 hours a week and they aren't really teaching much. But a lot of what people do with this software is a somewhat different type of analysis, often called machine learning. And one of the things about machine learning is the algorithms are supposed to learn. Traditional programming, traditional statistical analysis, people, the programmer, I don't want to exaggerate that we know what we're doing because, you know, there are lots of bugs, of course, but really the idea is that we know what we're analyzing, so on. Machine learning is much more opaque. They find patterns in algorithms with tons and tons of data, and they decide, and especially tons and tons of variables and ways of grouping variables that is not always clear. But you need to be careful with this stuff. Don't get me wrong, it's amazing, and there are a lot of wonderful things done from machine learning, as well as a lot of nefarious things done with machine learning, and a lot of nefarious things done by people who didn't even know they were going to do anything nefarious. And one of the problems, one of the reasons for that, is that machine learning is all based on prediction, not causation. Soon we're going to get into causation, and that's about what causes what, what's driving what, and having a model. Prediction is just predicting. Well, supposing you want to predict who to hire. You're going to train your machine learning on data sets from real people making hiring decisions. Things like that have the potential to reproduce discrimination, including unconscious discrimination and prejudice from people's things, without the people doing it even knowing that they're doing it. So this is a really interesting and important area of work. We're going to talk about causation, and I'll recommend some books, some works by Judea Pearl, but this is an important one. The opaqueness of machine learning is a problem. Another issue with this and how big data are gathered or used is, at what point does it stop being secondary data and really being primary data collection, where you're programming these bots, you're programming these algorithms to go out and do things and collect data and aggregate it and make choices in ways. It's not the original internet, droppings we left. It's something much more aggregated. So should we think of the software which does that as a form of primary data collection? Okay, well, as you see, I don't know a lot about this stuff. I'm still learning, and it's fast moving. But it's an important thing for all of us to think about. Now, some limitations of secondary data. The data availability can distort the research that people do. Because the data is there and it's easy to use, particularly if it's not big data, people work with it. So for example, in the United States, where health insurance is very fragmented, not everyone has it. There's a lot of different employer plans. There's all these different state Medicaid plans. But for those aged 65 older, as well as others, there's Medicare. And it's one federal system. And you can just get this data by applying to Medicare. And researchers can do that, of course, completely de-identified and so on. So, as a result, in the United States, a lot more research is done on Medicare than on the rest of health insurance because the data is available. That distorts what we know. So, when should you collect original data and not go with secondary data? You may not have enough data for a small geographical area. You might not have the variables you need. You might not have the relevant combinations of variables. Now, often you can link data sets, merge them. But if you can't, better go. May not be up to date, and you may not get the access to the data. Hi, so that's it for secondary data. I think you can all see how exciting it is now. And again, I want to encourage you for your capstone courses, which will come sooner than you think, to really think about secondary data. A lot of times people think of doing surveys, which are great, or collecting original qualitative data. But think about secondary data, especially in your own organization.